What's up, guys? It's been a little while, but we're here with the continuation of the scam car project, and this video kind of covers battery installation, controller connection, and then initial drives. We do get it working. We don't do a full test on it yet, and then we're still looking forward to putting in the new motor, and I guess ultimately before that, frying the old one, having some fun, seeing what it can handle and all that sort of things. But we'll get you guys a pretty action-packed short video that goes from it doesn't work to it completely drives, all in the span of 20 minutes or less. You know how it goes. So we'll go through some time lapses and some explanations, and we'll get you guys along for the ride. Working on some upgrades for this Scamborghini here, and we found underneath the bench seat in the front there is a compartment where there were 3 lead-acid batteries housed, 12 volts each, normal like car-sized batteries. Circuit breaker, 100 amps, looks like an AC breaker. May route it through it initially. We'll see if it causes a problem, potentially not. We'll figure that out. But I'm going to put this battery in there, bolt it down. Also open up the back seat, under which there are 2 more batteries for a total of 60 volts out of the 5 of them. And a controller here. Not sure the specs on this yet. I'll pull it out, I'll pull these out. But this is how it came. Motor is down there. The motor, size-wise, looks like it can handle more than 1200 watts like it's rated for. But these phase wires are fairly small. Generally these have thin shielding, so they could be 8 gauge. I'm not sure. I'd have to look at what the metal looks like once you pull out those ring terminals. But coming from here, this is a thicker silicone shielding. This is the traditional, like, thinner, less high temperature cable that goes to the motor. I'm guessing that we may just cook it once we crank the controller up. The controller is capable of tons of amps. So we're definitely going to have more power than these wires can handle, which will, at some point, if we do end up taking it to its limit, require replacement of that. But let's just time lapse it, pull this out, and get rocking. Got the old controller pulled out. Surprisingly large. For how large it is, it's not any heavier than you'd expect it to be. But for the 1200 watt rating, that's pretty abysmal in terms of size. I mean, I'm sure it's a very foolproof 1200 watts. Let's see what it says here. Doesn't really say. So the current of 55 amps, I'm assuming, let's see, it's 60 volts. That's a peak current of 55, so it peaks at 3300 watts. Just did the math on that. Continuous 1200. Maybe worth something. That's a 5 horsepower controller. Might be good for a project that we have coming up soon. I know that there's a quad to be converted into something fun, so we'll save this. I mean, for comparison, this FarDriver is probably close to 10 times the power. Same height, significantly shorter, about the same width. Yeah, same width, but much heavier. That's a solid aluminum heatsink on the back, whereas this thing's just got a heatsink as a body. The 84530 is a 5 kilowatt continuous. It is peaked at 330 amps. So let's do some math here. 330 divided by 55 times 88 divided by 60, close to 9 times the power of the other controller, or what the other controller was running. So that's quite impressive. 330 amps is massive. That will cook whatever motor is in there, 100% guaranteed. We will end up with that motor being cooked, I'm predicting. Maybe before we cook it, or we try to cook it, we have something already on order, since we'll recognize that we need one. But that will be an inevitable outcome. So let's just dry fit some of these components so you can see how ridiculously simple this is. There's a battery. That was both the negative and positive. And I just run the charger to this BMS. So that is the simplest battery installation I have ever done. Run one cable to the back, which will connect up to the controller, which sits right there. That will plug into the motor. We'll auto learn some figuring out in terms of like ignitions and things like that, but I can just run some connectivity tests to figure out which runs to which. We are going to use the stock DC converters, which are in the hood. 72 volt to 12 volt. This is 25 amps. This one is 10 amp. So whichever of these are going to, not a big deal. We're going to leave them all attached as they were stock, but we will just overclock them by, I mean, it's only like 14, 15 volts higher than it was rated at. It'll do fine. I've cooked things more than that before. So yeah, that's the entire workings of this car. It is the simplest little thing. It's listed at 70 or 60 volts, 70 amp hours. It's 71 amp hours. So if this is 71 amp hours, we have now downgraded to 3.3 kilowatt hours. Let's check what this works out to. If I have 24 at 3.7, I have 88.8 nominal. So if I take 3,300 divided by 88.8 nominal, it's a 37 amp hour pack. 37 amp hours is actually comparable to about a 74 amp hour lead acid because of the discharge curve being so inefficient on a lead acid. These are rated at 71 amp hours over their whole usable range, but the whole usable range is basically just a linear decline voltage for a lead acid, whereas it is more of a flat decline, which then tapers off at the end. So that is a whole bunch more usable voltage compared to a discharge curve that's completely linear effectively. So functionally it's not a downgrade in terms of amp hour rating. Additionally, it's not a downgrade because the usable kilowatt hours on this original system was only 60 times 30, let's call it 36 to round up. So that's 2.1 kilowatt hours. So we've actually got 1,200 more watt hours out of that compared to this entire thing. Each of these is about 40 pounds. I have to weigh it. There's about 200 pounds of batteries that came out and about 40 pounds went back in. So it is a massive lightening of this vehicle, let alone just the improvements that come with it. It's just, I mean, unbelievable. You can see how much space there is in this with just that one thing installed. So there we are. Maybe you can hear it, but right now it's giving me a temperature error. I'm gonna turn that to none. Save it. And now we're gonna go to auto learn. I'm gonna jack up the back of the car, go to auto learn and see what it does. That was aggressive. That was brutal. Hypothetically, it drives now. Let's find out. We're all good. Right now, I've just got to shift it manually. I can change it here. All right, let's take a drive. Alright, that was a very clunky auto learn. It obviously worked to some degree. I'm going to try doing a cap on the maximum. I'm going to put a maximum speed not at 12,000 but at 4,000 for now. We're going to try auto learn one more time just to see if because it was going to like 5,500 and this motor is not rated for that. It's like 3,200 is what it's rated at. So we'll put it at just a little lower and see if we can get a better auto learn. A bit smoother. It still shot up to 5,000, so this cap didn't work. I'm just gonna put it back up to 12,000 because our goal is to burn this motor up. We got a new one on the way. It's already in the mail. We know that it will burn, so might as well let it burn. It feels actually pretty torquey though, considering I was just barely pushing it around the yard and I could tell that it has a lot more power than it did before, that's for sure. So it's gonna handle more than the original motor was giving it. We'll just see how much that ends up being. And you can see we're gonna be putting 350 battery amps through it, 530 phase amps. So if we're at full ramp up, if we're at full motor RPM, it'll be getting probably with some sag, probably 30 kilowatts. And there's no possible way that motor handles anything near that. And the new one that we have won't either. There's a limit on how big these ones get, but it'll be better than we've got. All right, guys, I got this thing all fixed up as far as my expertise is concerned. Obviously it's going to get a beautification still and all that, but got the battery installed and BMS hooked up, discharge cables running through the original circuit breaker. But I did just connect up the positive discharge to the ring terminal of coming off of the circuit breaker, because if we end up frying that or end up blowing out these wires like a fuse, because there's like 8-gauge wire, I can just untape that and bolt that straight on. So we do have the ability to bypass it if it becomes a problem, but as of now we're going to have it running through there. The charge and discharge cables, obviously the positive charge cable, which is this thinner wire here, goes straight to the positive terminal. I also have the positive line for the DC converters coming off of here. I have another ring terminal there in case this fries. Again, I can connect this straight to the terminal of the battery. That, along with the negative charge and the discharge, goes through this hole in the bottom here. The negative charge comes in here, connects to BMS, which then connects to the negative of the battery. Very standard BMS connection. Those all concealed under the seat. Come out on the other side, underneath here. There they are. They come out that hole. I bring them over, have them zip tied into this groove the whole way back to the car, so that when you are looking at it from the body level, you don't see any hanging wires. And those pop out right here. Charge pops up, comes around, and then this positive and negative, the positive one goes here and pops into this, because this was originally the discharge, positive discharge of the battery, which I just converted to the charge cable. Those go into here and then up to the charger port on the outside, which we just have set up using this plug there, which connects to our standard charger. I charged it last night, but the outlet, it appears, is not alive. It got up to 98 volts, and I think it started pulling too much current. I think it tripped the breaker. I had it set at like 12 amps, 100 volts. So if it was a 10 amp circuit, even like a 15 with losses, it might have popped. So we'll, obviously the battery is fine still, it all works good. The charger wouldn't turn on. When I took it into the garage, the charger turned on fine. So I'm assuming that it's just the outlet and I probably popped the breaker, but it's only like a volt or 2 volts off of max, which is not much, so I left it as fine for now. These all connect up to the controller. Discharge is there. phase wires there. I didn't have to do anything to those except for drill the holes a little larger on that. Let me find motor cable here. This is the motor terminal, the motor cable here. What I did is I left it stock on the motor, and then I snipped off the original controller. I snipped off both the connectors. I snipped off the hall sensor motor connector and the general connector, which was this, which allowed me then to just solder up all of the existing, well, sorry, I could just connect the existing connector up. I had to just solder in the ones from this controller that I wanted to use. Obviously I've already bundled this all up, so I can't show all the details of what I pulled, but basically you can see from here I just snipped out one thing that was useful. In this case, this was the reverse wire. I snipped it out, I plugged it into where it belonged here as it paired up to that based on turn the key on, do the switches, find which wires were connected to which, then I would snip them and match them to the corresponding wire on the controller. It was only a few hour process to get all those connections figured out and connected. Obviously the soldering is a very small portion of that. The main component is figuring out which wire connects to which. This controller, as I understand it, and maybe somebody in the comments can correct me, but I was looking through the wiring diagram, I did not see a wire that was drive. What I saw instead was a reverse wire, but then no drive wire, just the speed selector and a few other things, but there was nothing that was specifically a drive selector. So what I did is I set it to default drive. So if I look at my switch up here, there is no neutral. Neutral is drive, drive is drive, and only in reverse will it be reverse. So there is no neutral in this anymore, which is fine. Just don't push the accelerator, right? Turn it off if you're not wanting to drive. But it was a pretty simple process. This motor, I've already driven it around a little bit. Small-ish motor. I would say it's 6 inches left to right. So it's able to do a lot more than it was being asked to. I will demonstrate. I've changed no gearing because obviously it's the same motor, same differential. The only way that I'm able to change that is getting a motor with different winding, which a motor with different winding is on its way. It gives us a higher top speed. It's also got, the motor that we're getting has a higher amp rating, higher current capacity, and so we'll be able to turn the controller up higher, so not sacrificing acceleration hopefully, but also getting a higher top speed out of it. Regardless, this has bumped from like 70 volts max to 100 volts max, so we're going to get an extra 40% out of it top speed just as it is, but the acceleration gain is incredible. I will show you guys. I haven't gotten any more driving than just across this stretch. There is a car blocking my exit to the road, so I haven't had a chance to like take it out and do some real test driving, but it is much more peppy than it was, partially due to the 200 pounds of batteries that have been removed. This is a massive amount of weight to pull out of that, replaced by 45 pounds or so total, so that's pretty incredible. Yeah, really it was a simple process. I didn't change any of the 12 volt system. That was all good. I just had to put a new battery under there, put a new controller in, and then figure out what wires connected to which so I could get that controller fired up. It just required connecting the orange key switch, which is orange on all of these controllers. It required me finding the 3 throttle switches and 3 throttle wires and plugging that up. And I plugged in 1 reverse wire. So that's a total of 5 wires. So for 5 wires, you get it fully functioning with the system that was here. And the only one that gave me trouble was figuring out which one was reverse because connectivity was questionable on certain things. I'm not going to put anything back on yet because Angel still wanted to do a kind of a walkthrough description. This was my trial run. But I will just set this on the tripod and let you guys see it do a little quick burnout while I accelerate, and then we'll do some real test driving, on the road, test driving for the Engines channel. So there it is. Try to let it put the power down this time just to get the best acceleration that we can. No burning out. And since the filming of this video, we did get the new motor in. I have not installed it yet because we have to cook the old one still, but it's got a significant upgrade in terms of phase wire size. And you can see if I line that up on that end, there's a significant increase in size and current capacity, part of that being associated with the size itself. So we'll have faster top speed winding, higher ability to run higher current, and so it should actually have a significant improvement in overall acceleration and top speed if we can get that to connect correctly. I'm assuming it's a drop-in replacement. It's the same connections, it's the same appearance, and so my only concern would be that this is not a standard splining that connects to this differential. I haven't got a chance to pull one off and see if that's the same yet. I'm assuming it is. It's apparently these are designed for trikes, electric trikes is kind of what this rear axle comes from, is what I'm seeing around, and obviously when I shop this out, this looks so similar to that I feel like it has to be the same thing. We'll pull it off before we burn it just to make sure we have the ability to replace whatever there is. You can see this one was not handled well at the factory, to the point that it actually broke off one of the connection tabs that I need. It should look like that. This one even is a little squished. But those get bolted on the back there. You can see it, the tab is needed. So I might see if we can get a refund on this, see if it still installs, and then if not, we'll have to get a new one. If it doesn't install, then of course they'll have to give us a refund. But I think we can get a refund and maybe make it work. That would be ideal. Is that dishonest? Let me know in the comments below. It's got a good bit of weight to it though. It's probably close to 20 pounds. And you can see the phase wires on this side. Not as big as I might have liked, but definitely bigger than the last bunch. So that's gonna handle more power. I'm excited obviously for the next things on this, and mostly to get it out on the road and see what it can do. I'm guessing top speed roughly 40 miles an hour or so, and then our new motor should push that over 50. So we'll see what we can do. But till then, I'll catch you guys later.